Okay, the main reference I'm using for this course will be the first one, the Montgomery, the 2009 Design and Analysis of Experiment is a 7th edition. But of course, if you have a latest edition number 8, also they are the same. Or if those students who have an older edition, you still can be use it. But my main reference or my lecture notes basically will come from here, from these books. Because this book is more is easy for you to understand. The writing way is very simple. Okay, so you can refer it every time. I will give you the slide. Then that one is get from here. Okay. Then the second one is I will using the second books is this book. Okay, this book basically almost the same as the previous one, but in this book they are more concentrated on the response surface methodology. Okay, so about the robust design, I will also get from this book. Okay, so therefore this two is the main reference for the textbook. Of course, you have another 3 textbook you can be use it. You can check out those of the books involved in the experimental design, and then they're talking about the different type of designs. Then you can be use it as a reference. The techniques, they are more the same, only the presentation may be different. Okay, so as I mentioned to you, this one is the main textbook I'm using. You can use other edition, but if you're using the 7th edition, then the flow will be the same. But you use the other edition, maybe the flow of the examples, they are not follow my lecture notes. Okay. Then this the lecture and the tutorial in this course, we have a lecture and the tutorial. I will show you some codes to run the results. Okay. So here is times for you for the student preparation times. So most of our lecture I will go through is a face-to-face. Means that I will go through is a live lecture instead of I upload the video and then let you to go through. Okay, so I will go through is a video session. If you cannot follow, if you feel tired, then you later on after I uploaded the video, you still can review the video later on. Okay. So this one is all the time here. Okay, so the skill is transferable, is communication skill and the data analysis. So this one is my name. If you have a chance to come to the University Malaysia, then you can view the department. Okay, we have shown to you our department website. So if you have any information, you can refer to our department website. And then this one is my room number. This one is my telephone number in my office, and then my email address. Of course, you also have my mobile phone number. If you have anything, you can contact me through the mobile phone or through the WhatsApp. Okay. So the following one will be the lecture time. Basically, our lecture time is starting from the 6 until the 9:30, where they have in between there is around 30 minutes break. Okay. So this course, because we have a tutorial section, so the lecture will be starting from the 6 until the 8:30. Then after that should be the 8:30 until the 9:30 is a tutorial time. So because we have a break in between, okay. So therefore, I think that to be considered the Muslim, they want to go for prayer. So we roughly will stop around 30, okay, 7:30 until the roughly around 8 o'clock. Okay. So this one will be readjusted from time to time, but basically our lecture time is from 6 until the 9:30. So the platform we are using is basically I have added all the students in the Microsoft team. So you are using the Microsoft team here. Okay. So now we have go through the breakdown of the assessment. So we have a first one is a test 1. We have a test 1. We have a test 2. So these 2 tests will be the written exams. So I give you the question, then you just answer the questions. Sometimes the statistical output I will given to you, then therefore you no need to deal with the very long computation. But some of the question you need to do so because some of the crucial part you need to do it. Okay. But of course, the test 1 and test 2 you do it at home. So you can be referred to any formulas. Okay, it's considered as an open book. So you can have a refer to formula. Then after that, we have a group assessment. The group assignment. So the group assignment, I will have a 10%. So in this group assignment, basically, I will ask you to refer to the real application of the design or experimental. But if you want to get the data from the private sector, it's very hard. So in this group assignment, I will ask you to get the survey, just a survey work from the journals papers, because those of the published journals papers, there are data set or they have a real application they were presented in the journal papers. So our assignment will basically like the survey of the do the survey on the design or experimental. Okay, so I will inform you later. Okay, so but this one group assignment, just a group work, is not the individual work. Okay. Then after that, we have a final examination, is contribute to the 50%. Okay, so a total out, you have a 100% of the assessment. Okay, so bear in mind that you know that because a master degree, if I'm not mistaken, at least you need to get the B onward for your grade. Okay, I believe that is a B onward. So make sure that you work hard, not only my subject, you also need to work hard for other subjects, because the master degree is similar to the undergraduate or the bachelor degree, where they do not have a certain cutting point. Okay, they belong to the first class, second class, and the second upper, second lower. But the master course, there is a certain cutting point. So you make sure that for all the subject, you need to pass, not only the pass, you need to achieve certain grade. I think all these things is stay. Either it's your offer letter or the rule and regulation. You can go to check it out. If you're not sure, you can be consult the program coordinator. Okay. So far, any of student have a problem? Before I proceed with the weekly activities.
No.
Okay. Yeah. If you have any question, you can be raised out to me. Okay. Thank you. Yeah. Okay. So our lecture time is altogether, it should be the 14 weeks. Okay. Altogether, we have a 14 weeks of them. Okay. So the first for the first week, I will do the introduction for you. What is the experimental design? Okay. I will just go through the brief introduction. After that, we go through the completely randomized design and the randomized complete box design. So these two is an introduction for you to later on you carry on with the factorial design. Okay. So if you're using the textbook, I refer to the textbook number 1. If you have a textbook, then you refer to the chapter number 4 and number 5. Okay. Then after that, the second week, I will go through with you what is the factorial design. Okay. Okay, following after we completed the randomized design for the one factor, then you can be extend it to the idea of the factorial design. Okay, so from the factorial design, we will go to the week number 3. We also continue with the factorial designs, but of course in the factorial design here, they will cover the factorial design with the blocking effect. So even though I write it as a general one as a factorial design, but they will cover the blocking here in the factorial design. So in the week number 3 also, after you know what is a factorial design, we will go through the special case of the factorial design. It's called the 2-level factorial design. Okay, so these 2 chapters will appear in the chapter number 5 and number 6. Okay. Then after that, we will continue for the week number 4. It's a 2-level factorial design again. Okay. So inside the 2-level factorial design, we also can have the blocking effect inside. Okay. Then after the week number 4, we will continue with the one. It's a technique. It's called the blocking and the confounding techniques. Okay. So in detail about the blocking and the confounding, I will discuss with you in the week number 5 in the chapter number 7. But for the blocking here later on, if today we can finish it, you also can see that what is meaning by the blocking is the idea of here. So this one is why I need to introduce for you this thing before you can go to here. For those students who are don't have any background, I found that some students maybe they are not from the statistic background, okay, from engineering. Maybe engineering you are fine, but if you are, let's say you come from the IT, then you may be not familiar with this term. This one is a reason I have to give you some introduction. So for the week number 6, I have an overlap also. It's a blocking and confounding. I continue the blocking and confounding. At the same time, after we complete the factorial design, 2-level factorial design, we will go through, it's called the fractional factorial design. So this fractional factorial design, we will concentrate on the 2-level fractional factorial design. Okay, so they may not be any factor. They only concentrate on the 2-level case. So and its restoration. So in the fractional factorial design, you need to know a lot of the terminology and what are the how you want to divide them into the fractionals, and then you also how do you want to take out for the certain fractional design, and then you make the conclusion for the result from the overall factorial design. Okay. So this one is in the week number 6. So in week number 7, we also will concentrate on the fractional factorial design. Okay, so this one I just repeated it and repeated here because we have a test 1 in the week number 7 before the holiday. Okay, so we have a test 1 here. So this test 1 is a written exam. Okay, so depends on how long. Normally the test 1 will be take for 1 hour. Okay, 1 hour, but I will give you some time is for uploading the solution, and then some time before that to download. Therefore, the plus or minus, they may be take more than 1 hour. Okay. So this one is for the week number 7. So after that, you have a break for 1 week. After the week number 7, you have break for 1 week. But over here, my planning here, I just write is 14 weeks. You have a break 1 week, that one I don't count it. So I consider that one the next after the holiday is a week number 8. So the week number 8, if the fractional factorial I still cannot complete, so I will continue the fractional factorial design, the fractional factorial design and its restoration. Then after that, I also introduce for you all what this one is just the introduction. Okay, because I also consider those students who don't have the idea what is meaning by the linear regression model. Okay. Okay. So in the week number 8, we will go through about this thing. Okay, but the linear regression is not our main concern. Okay, we need to use these tools in the response surface method and design. Therefore, I need to introduce for some of the students who are not familiar with it, is about this thing. Then the week number 9, we will start with the response surface method and design. Okay, so we take a few weeks for the week number 9, week number 10, and the week number 11 for the response surface. Okay, so after that, we have the following one. The following weeks will be mentioned about the robust design and the robust design for the week number 12 and the week number 13. Okay, then of course, we have a test 2. Test 2 is a week number 12 here. Okay, so the week number 12 here, we will have another test. Yeah, we have another test for the test 2. Okay, so this one is in the week number 12. Then after that, we continue our lecture here. So during the week number 14, we will have a discussion. If the lecture cannot finish, then we will continue with here. Then of course, the discussion here is during the week number 12, when you have a test, the test question, I also will discuss about how to settle the exam question for the test in the week number 14. So even though for the test 1 also the same thing, after you have a test, after I'm marking, I also have a discussion with you, or after I have finalized the results. Okay, then we have a discussion maybe at the 9 or 10. Okay, then about this thing is planning for the lecture class. Of course, you also still have a tutorial classes. Okay, tutorial classes is I leave it for you to give you some exercise, then you do it. Then during the tutorial time, we do the presentation so that you're familiar about how to do it manually, or you can use a software to do the calculation. Because when you study the statistic or the statistic course, you need to know the idea behind that. You cannot just depend on the software, you click, then you get the results. Because different software will give you the different sometimes you assume that this one is a meaning, is, let's say, for example, the residue in this software, and the other one in the other software, maybe they call another name. Therefore, you the theory behind that, so that when you do the calculation, you are able to do it manually, as well as you use a software, you can click the results. Okay, otherwise you may face a difficulty on all these things. Okay, so this one is here, and then just now I mentioned for this course you have a tutorial. So the tutorial section may not be have every week. So if we have a tutorial, because the first 2 weeks, I believe that we do not have any tutorial section, because we still need to complete the discussion first, then the tutorial will start on the week number 3 onward. Okay, yeah. So this one is about the course content. Any of you have a problem? Okay, you can get all this information in the Spectrum system or in the Microsoft Teams. Okay. So if you want to look for the books, these two are the main reference I'm using. Okay. Okay. If you have a question, you just interrupt me. Otherwise, I will start. You have any question or not? Okay. There is if you don't have, I have one question to ask you all first, because I want to know your background. I want to know the student background of on this course. Okay. So may I know you yeah. Where can we buy the books? Basically, the books one, you can go to the the online to buy it. But I don't know whether you are allowed to come to library or not, because our library we have a quite number of copies of this book. If you're allowed to come to the library, then you can what? You can borrow it. Okay, you make sure that as we mentioned in the research methodology course, you please make sure that you log into the register for the library, so that you can access the material. So the library, maybe they have a soft copy of this book, then you also can get it. Of course, if you want to buy the books, you can go to online to find it out. Nowadays, I think bookstore is very hard, because they do not keep the stock of the books. Okay, unless the student is come to the uni, then the keep the stock. Otherwise, nowadays they seldom keep the stock, unless you go to those of them, they sell the university books one in the, if you are in the Kuala Lumpur area, you can try for the Kuala Lumpur area, like the university bookstore, see whether they have this book, they keep the stock or not. Okay. Yeah, sometimes this book also you can share it in the online. You also can download it from there. Okay. Any question? Any more question or not? Okay, you do not have any question. Okay, then in that case, I just ask a question. may I know any student who totally don't know about just now when I discussed the content about the factorial design? You have a question? Okay, somebody have shared it. Oh, library, yeah. There is a, oh, I think somebody have shared it in the message. Yeah, you can get it out. Okay. Okay. Before I continue, just now I mentioned about the content of here. May I know any of the student who don't have any knowledge on this course?
Hi. Yeah, I don't have much background in stats.
Okay. So hold on. Maybe I open out I'll share one. Let me just take it out. Who is it don't have the background? At least I just want to survey. You know. Yeah. I just want to survey how many of them they don't have background only. Okay. So just now who is it? What is your name?
It's Lim Ka-shen, the second one.
The second one, okay.
Yeah.
Your background is from the?
I'm from a CS background, computer science.
Computer science, okay. Then who else? Who else they don't have a background of this course?
I'm Yu Tongfeng. I'm from physics background.
Who is it?
18.
What is your name?
18.
Number 18. 18.
Yeah.
Oh, okay.
Oh.
So you totally don't know about the content of this course, correct? Yeah.
I didn't touch in detail.
Okay, sure. Then okay, then the sun class. Who else?
Number 12.
Number 12.
Yeah.
Yeah. How about the rest? Maybe during your I've learned it before. Number 4.
Yeah.
Then Colleen also you don't get you also don't have. Number 16 also you don't have. Then who else? Is it that's all?
Then I think I only know the linear regression model.
Okay, you only know the regression, but I think that since look like it's many of them they don't have the knowledge on this course. Okay, because maybe your background is not come from the statistic. If you are your statistic background, I think most of the university they have offered this course, but not necessarily all. Okay, so it look like it's quite around 10. Okay, I no need to put the anymore. I just want to know how many of them only. Okay, yeah. Then I may go through not too fast. Okay. So I have uploaded the information, the notes here, but the notes sheet there is not the complete one. But here I will give you explanation at the same time. Sometimes I have written something, then I will put it. Then I will put the writing parts here. Then you can be. I will upload it to the. Okay. I will upload this thing to the Spectrum, even though with my handwritten, I will upload it so that if you don't want to view the video, you still can be reading from here. Okay, so you have a few sources. Then if you, I think one of your friends is share the book link, then you can get the book. At least you know about the detail. So for this one is what we call as an experiment with the single factor. The approach we are using is use the analysis of variance. Okay, the short form of here is the analysis of variance, or you can see that sometimes they put the name as a ANOVA. Okay, for those of you who are familiar with. It's an ANOVA, analysis of variance with short form is ANOVA. Okay, so in the first part, I will introduce for you experiment with the only single factor. Okay, so what is meaning only the single factor? So let us go through the next slide. Okay, so before we go through the single ANOVA, I will let you know very simple the statistic what you have learned before. The experiment, the simple comparative experiment. If you are the statistic background or not statistic background, if let's say I want to compare for the mean, the population mean. Okay, let's say I give you the example. If I want to survey or the average GPA, CGPA for the student from the statistic, the Master of Science in the statistic until the current year. So if I cannot collect all the information of the student, I only collect the parts of the students. So it's become my sample. So I'm interested about what is the overall mean, okay, the overall population mean. So I will base on the sample to make the conclusion about the population mean. So the sample results I have is I use a notation as a sample mean. I use a notation as a X bar. Okay, I will collect the sample mean result is a X bar. Okay, so I'm interested about the population mean. Okay, so this population mean, I assume that is an unknown. Okay, if you know the population mean, you totally no need to carry out any of the sample. Okay, so therefore the population mean is unknown. You collect the data from the sample. After that, you use the sample result to make the conclusion about the population. So therefore, we need to carry out the test. So that test is called the hypothesis testing. So if we are interested about the one population mean, hypothesis will be testing the mean will equal to the, okay, I write properly. Equal to the mu naught, okay, where mu naught is a certain value, and then versus the H alternative, the mean will be greater than the mu naught, okay, or you can have the mean will be less than the mu naught, or the mean will be not equal to the mu naught. Okay, so you have a alternative hypothesis, you are testing for the three. The null hypothesis, you are say that your population mean will equal to the mu naught, where the mu naught is a constant value. Let's say I say that the population mean, the average value of the CGPA for the Master of Science student is equal to 3.5. So indeed, this claim is, I need to collect the sample. If I cannot survey for all the students, I just collect the sample of them. Then I make the conclusion whether based on the sample result, whether I have a significant evidence to reject the H naught or do not have a evidence to reject H naught. So this one is about the hypothesis testing of the one sample case. And then in the one sample case, you are based on the T test. The T is stand for the T distribution. Okay, when you go through the statistic, you will learn the distribution. I believe that majority of students, you heard about normal distribution. Okay, normal distribution. Then you have another one is called the T distribution. Okay, when is it you use distribution in this case? When the population variance is unknown, therefore you base on the T distribution. So in this example, if let's say I carry out the T test, one sample T test, it will have a test statistic. Okay, will be equal to the T value will equal to the X bar minus the mean divided by S divided by square root N. Okay, S is stand for the sample standard deviation, then the square root N is stand for the sample size you collected. Okay, the X bar is your sample mean, your mu is refer to the population mean, so I can put it as a mu naught. Okay, so this one is I think that if you learn the basic statistic, you should be get it out. Okay, so this one is a testing only the single population. You want to test only the single population. As I gave you the example, if I want to know the average CGPA for the student who are major in the Master of Science in Statistics. So I concentrate on this part. Okay. So from the one sample, you will go to the two sample case. For under the two sample case means that we are testing for the two population. So using the similar example, we were testing of the average CGPA of the student for Master of Science in Statistics. But we divided the student into the two groups. We are interested about the gender, the male and the female, the performance of the male and the female. Therefore, we have a two different population, but we are interested on the CGPA. So the results we have is a CGPA. Okay. So in the two sample t-test, then we have the null hypothesis. We have a mean 1 is equal to the mean 2. We have a two population where we, under the H0, we always assume they are equal. So under the H1 alternative hypothesis, we can have a from the first sample were greater than the second sample, or we can have a first sample were less than the second sample, or we can have a 1 is not equal to 2. So this one is a hypothesis we are going to test. For the one sample is under here because it's only one single population. This one is we are defer to the two population. Then we compare the male and the female groups, or we compare the student from the different faculties. Okay, so these are the two sample t-tests. So they are using the t-test because they based on the t-distribution. Okay, so about this thing, you need to check it out. Okay, what is a t-test? What is a normal jack test? Okay, sometimes they use a jack test, so you need to familiar with it. Okay. So under the comparison of here, when you want to carry out all, you need to know that what are the assumptions of the data. Okay, you need to make sure that you are using the correct test. Means that they fulfill the certain condition. If they do not fulfill the condition, you force yourself. Let's say, for example, I have a data in the software. I have a data, then I put in the data in the software. Like for example, the SPSS, or you use the R programming. You do the directly analysis, then you get the result. You don't care about what is the assumption or the model assumption. Then the misleading results. So this one is a reason why you study the statistic. You need to know the idea behind that. Means that they must fulfill the certain condition. If they do not fulfill the condition, you force yourself to do the analysis. Of course, you will get the result. You put in any data in the statistical software, they can come out the results. But the result will be give you the wrong results, or the result is cannot be acceptable because they have a violation of the assumption. So under this thing, you need to checking the assumption. How to check the assumption? Of course, we will check the histogram of the data, whether they fulfill the normality assumption or not. Instead of plotting the histogram, I believe that you have learned before what is called the goodness of fit test. Okay, you use a statistical software, you can check it out. Okay, I want to know that is it this data is look like a normal or no. So I can use the normality. I can use histogram to view it graphically. I can use a QQ plot. Later on, I can show it to you all these things. Okay. So this one is the first one is talking about when we want to carry out the very simple comparative experiment. Then we will concentrate on the one sample or the two samples. So as you can see out just now, I want to compare it's just the student CGPA. CGPA is a cumulative grade point CGPA average. Okay, so you every semester you complete the study, you will get your GPA. Then if you cumulative for a few semesters, then you get your result is a CGPA. Okay. So my target is want to study is a CGPA of the student. So, but I have one group of the student only because I just consider those student is major in the statistic. But this one, we have two groups where those students is a major in statistics. Then at the same time, they have a different level. You have a male and the female. Okay, so this one is only for the first case of the simple case. Now our idea is want to go through, means that we can have more than 2 levels. Instead of the 2, we can have more factor levels. Means that we call the name as a levels. Just now I give you the gender, you have a male and female. Let's say I want to compare another thing is those student is from the Master of Science in Statistics, but I want to compare is those student the first semester register, the second semester, or the third semester student, or the fourth semester student. So I have more than 2 levels. Okay, this one I call it as a levels. So therefore, we are using, it's called the analysis of variance. Okay, if you have only 2 of them, then you can be compared using the t-test. But if you have more than 2 factor levels, then you need to have to use the analysis of variance techniques to do the analysis. So this one is what we call as a ANOVA, analysis of variance. And then we study only the single factor here. The single factor we are referring to we are interested about the performance of the student. Okay, we are doing a performance of the student of the different levels. Okay, so if you have 3 levels, more than 2 factor levels, it means that let's say we are considering the student for the first year or the first semester, second semester, and the third semester. We are do the comparing of the 3. Okay, so that one is called using the analysis of variance. So when we write down the hypothesis, of the three level, so this one is for the 2 samples. So we will have a H0, mean 1 equal to mean 2 equal to mean 3. Under the H0, we will say that all their means is equal. Okay, if you have a more than that, then you equal to a more than that. Okay, under the H0, they are equal. We will reject the H0 if any of the pair they are different, then it reject H0. Okay, so in detail, I will let you know later. So using the analysis of variance, the idea of the analysis of variance is just decomposition of the total variability. Okay, they try to decomposition of the variability. So variability is means that the decomposition of the variation of the data. Okay, so I will show you how the decomposition of the variability. So variability, we can consider it as a variance. Okay. After that, after you know how to decomposition it, then you need to know that what is the distribution to be used. If you have that particular random variable, you need to know they follow what type of distribution. Like this example, the one single mean, we will know that using the if the sigma is unknown, then we can using the t distribution. T is stand for the t distribution. So if you after you decomposition of the total variability, what type of the distribution is useful for testing this type of the variability? So we need to know the statistical testing and the analysis. Okay. You able to carry out all this testing and the analysis. Then after that, we also need to check the assumption. So we need to checking the assumption, the model assumption, whether they fulfill the condition or not. Okay, if they fulfill the condition, that means that your presented result is valid. Okay, so this one is number 3rd one. Is followed by, just now as I mentioned here, you are comparing the mean 1 equal to mean 2 equal to mean 3 or the so on. The H1 here, you are comparing if the H1 is means that you cannot say mean 1 greater than mean 2, mean 1 greater than mean 3 or less than and so on. So in testing the ANOVA, what our hypothesis now and alternative is just testing the equal and the H1, they are unequal only. So we want to know that which pair of them are equal or unequal, then we will carry out what they call as a post-ANOVA testing of the mean. So this thing I will explain to you in detail. Okay, so our and this course we will concentrate on this part. This part you can go through any of the elementary statistic books where they tell you about the application. But if the theory, why we using the t distribution, why is you not using the normal distribution, that one you need to learn about the theory, what happened. Okay, so we are concentrating on this part here, starting from here. Okay. So in the analysis of variance, we cannot be directly use the t directly. Okay, the t test cannot be tested directly. The reason of the t test cannot test directly is they cannot test directly is I referring to here. They cannot test directly is because you have more than 3. Okay, you have more than 2. If you want to compare the 2 pairs, you can and the 2. You can compare the 1 and the 3. You can compare the 2 and the 3. Do it separately. It's possible you do it separately, but the problem is if you do it separately, you will affect certain constraints. So therefore, we are not do it separately. We will do all the comparison at the same time. Okay. So therefore, here we will say that the t-test does not directly apply. Okay. So there are lots of the practical example where there are either more than the 2 levels of interest, or there are several factors of the simultaneous interest. So you bear in mind that the levels and the factors. Okay. So for the first one here, I will only study the single factor first. Okay, you only have a single target, but under the single factor, you consist of the many levels, more than 2 levels. Okay, so over here, I have mentioned to you that we can have a study more than 2 levels, or we can have many factors. Okay, so means that we have a factors A. Factor A, they consist of the many levels. 1, 2, until the A levels. Okay, they consist of here. We can study also the factor B. So under the factor B, also we have many levels from 1, 2, until the B levels. Okay, so this one is in the one-way ANOVA single factor. We only study the single factors with the A levels. You also can study many factors at the same time, okay, with many levels. Okay. So the analysis of variance ANOVA is the appropriate analysis engine for this type of the experiment. Okay, so we are using this type of experiment to do the analysis. So when is it the started of this ANOVA? The ANOVA Fisher in the earliest 1920. Initially applied to the agriculture experiment. So because when they do the agriculture, they want to know the plants, if they different type of the fertilizer, is it they have a different the growing or the yield of the fruits? Yeah, so therefore they come out at the beginning is applied to the experimental the agriculture experiment first. Then slowly they will go to the industry. Okay, use assembly today for the industry experiment. Okay, so more example I can show you later. Okay. So in this one is I give you the first example. Okay, so in the first example, we are studying this example is I get free from the textbook. Okay, because they are more to the engineering background. For those from the engineering backgrounds, is maybe you are not familiar with all the terms here. Okay, but we are concentrate on those of the statistical the analysis or the tools. Okay, so in many integrated circuit manufacturing steps, wafers are completely coated with the layer of material such as a silicon dioxide or the metal. Okay, so the unwanted material is then selected and removed by the etching through the mask, thereby creating the circuit pattern, electrical interconnect, and area in which diffusion of the metal decomposition are to be made. Okay, so this one is talking about the background of the study. Okay, the full detail of this one you can be checked from the books. They will tell you in the paragraph form. Okay. So what I want to concentrate on here is just the diagram of here. What they want to concentrate on here is about the RF generator here. They want to concentrate on the RF generator. Say that energy is applied by the radio frequency, the RF, okay, generator, causing the plasma to be generated in the gaps between the electrode. So we supply the energy by the radio frequency. Okay, so supply the energy. If in that case, if we can supply as much as possible the energy, but if you supply different energy of the weightage of the energy, is it they give you the yield is higher or lower? So this one is in the whole story. They want to concentrate on this part. It's a RF generator. They supply the energy. So if they're using the different level of the energy, is it they will affect the results or not? So then after that, they suggest to the company, say that, okay, I no need to use a very high energy. I use a very high energy and low energy. I will get the same results. So this one is what they are going to compare. Okay. They want to compare here. Okay. So in this example, because I mentioned it's about the RF power, so the engineer is interested in investigating the relationship between the RF power setting and the each rate for these tools. So they want to know what is the setting of the RF, so that they give you the different each rates. So the objective of this experiment is like this. To model the relationship of the each rate and the RF power, and to specify the power setting that will be give a desired target each rate. So they want to know that what is a power setting so that you get the desired each rate. Okay. So therefore, when we get the experiment, we get the answer or we get the response data, then the response variable is called the each rate. So normally the response variables, you are using the notation as a y. Okay, if you study the relationship of the equation, let's say y equal to the mx plus c. So the y is called your response variable. The x is independent variable. So the response variable, most of the time we use a notation as a y to represent it. Okay. So now the Y is your data set you obtain where you do the measurement. So she is interested particular in the gas for here, and then test for the 4 levels of the RF power. So they use the RF power at the 4 different levels. The power watt. The first one is 160, 180, 200, and 220. Okay. So they want to test that at the 4 different levels of the district. Okay. So she decided to test the 5 level of the RF. Because if you still remember, you recall back what you have beginning, I'm testing the comparing the mean. So therefore, when you collect the data, you need to have a few observations so that you can get the average value. Okay. So in this case, we can say that they consist of the 160 watt until 220 watts. Okay, and then each one they test at the 5 wafers at each of the level of the RF. Okay, so I can give you the notation here. It means that the experiment will choose the 4 levels here. Okay, they only study the single factor. What is the factor? They want to see that what is the RF power performance, okay, on the each rate. So under the RF power, the main factor is the RF power, but the RF power, they consist of the 4 different levels. Okay, so if you have 4 different levels, if we are talking about mean, then you have a population mean of from the 160, 180, 200, and 220. Okay, so for each each of the power level, we repeat the experiment for 5 times. So in the ANOVA, we call as 5 replicates, or sometimes you can see that the runs, they use the name runs, or you repeat for 5 times. Okay, then of course, when they run the experiment, they must make it in the random order. Okay, they cannot be say that this observation must belong to the first one. This observation must be run for the second one, and so on. Okay. So you can see that this is an experiment they obtain. As I mentioned here, you consider about, before that, you don't have the data set of here. You consider the 4 levels here. Okay, it's 4 levels. So for each levels, you repeat the experiment for 5 times. So this one is referred to the is equal to 5. Okay, you repeat the experiment for 5 times. Okay, so this is empty. Before that, this whole thing is empty. Okay. So how are you going to run the experiment? Before that, all this thing is empty. So you know that you have 4 levels to consider, and then for each one you repeat for the 5 times. Okay, so means that overall you need to have 20 observation. You need to have 20 observation. Okay, so the 20 observation you want to test it that time, the 20 observation must be assigned to the different combination randomly. So this one is a keyword what I say. You assign it in the random manner. Okay, means that you have a 20 observation, 20 units of the observation, and then you assign it as a random. You order it. For example, you have a Y1 until you have a Y20. Okay, so for the Y1, is it the observation number 1 must observation 1. Observation number Y2, they go to here. If you do in this way, then this one is not the random anymore. So you should be randomize this number, then they reorder. Let's say they reorder is become the Y3, then Y5, then Y20, and so on. The last one may be Y2. You reorder it, so means that the observation number 3 will go to the first cell. The observation number 5 go to the second cell. So this one is called that they must be randomized it. Okay, you cannot have a fixed pattern. So after you randomize it, you know that this observation, they put it, then they do the measurement, they get the each rate is a 575. And then the second observation, they do the measurement, then they get the each rate is 546. After that, they get all this, they run the whole experiment, they will get all the 20 observation here. Okay, so after you get the observation here, before you study any ANOVA techniques, what you can see from the data here. What maybe you want to compare, is it the different RF power will give you the different mean or not? Therefore, what you can do, the first one is you get the average value for each row. It's a 551.2. The second row average, you get this thing. The third row average, you get this thing. The fourth row, you get this thing. So from the average here, you will see that, okay, if I use a RF power 220, they give me the highest mean. If I use 180, using 180, I get this thing, I get this thing. Okay, so before we go further, continue with the ANOVA analysis, we do the analysis of the data set. So after that, you will ask a question. The changing the power change the mean of the each rate, because this one is a mean, is the average value. If you change the power level, of course, yes, they change the mean rate. They change the mean of the each rate. Okay, as you can see up there, keep increasing. Okay, so is there an optimal level of the power? Is it I must use a 220, or I use a 200, or I use a 180, or I use a 160? Is there any optimal level of the power? So this one is what we are normally based on the data head we are going to ask. Okay, and then I also can plot the this one is called the box and whisker diagram. Okay, the y-axis is each rate, the x-axis is RF power, the RF power 160. Because I have 5 data here, I can draw the block plot. I can draw the box plot here. As you can see that there is a trend increasing. Okay, similarly, if you refer to the mean here, you also can know that they are increasing. Okay, so when you want to present your data, you can use a numerical values or you can use a graphical way to present your data. So you can see that the mean, of course, this one is to not show the mean, it show the box plot is showing the median. Then you can see there is a trend is increasing, similar to the values here. Okay. So after we analyze for the data over here, before we go through the test for the ANOVA, okay, so this one is an observation what we can see. So means that if somebody use a 240, you may expect that the mean will be increased. Okay, if you use the 260, then you know that the mean will be increasing. This one is a maybe based on the observation of here. But is it this one is a true or false? Okay, we cannot make any conclusion outside than the 240 and 260 because we are doing the analysis on all levels. Then our conclusion later on will based on all these 4 levels to suggest to your company which level I should be used. Okay, if let's say the optimal one is a 200, then I should be used at the 200. Okay, later on you can see the explanation. So after all this data, after you get all this data, all these things is just a descriptive statistic. Just describe you have. Okay, for those of you study the statistic, you know that statistic belong to the 2 categories. One of the category is called the descriptive statistic. Another one is called the inferential statistic. Okay, descriptive statistic is like this example. We calculate the sample mean, we draw the plot, all these things. It's just a describe the statistic you have. But after that, you want to make the conclusion of the results. So in that case, you need to carry on the hypothesis testing. So in that case, the ANOVA will be come in. Okay, so this one is similar to what I show you here. You're testing the population mean, the hypothesis testing. All these things is called the inferential statistic. You want to make the conclusion of the population based on the sample result. So this one is called the inferential statistic. Okay. So just now we have analyzed the data. The data is given by this thing. Now we'll go through it to do the analysis of variance. Okay. So just now you can see that I have 4 levels of the RF power. Okay, so I want to testing the equality of all means. It means that if I want, I'm testing the H0 mean for the 1 equal to mean for the 2 equal to mean for the 3 equal to mean for the 4. So 1, 2, 3, 4 is referred to the 160. Okay, so this one is 1, 2, 3, 4 represent the 1, 2, 3, 4 here. Okay, so our ANOVA, why we need the ANOVA? Because we want to test, is there any difference in the 4 means or not? In the population the population mean. But clearly, if you observe your data here, all these things is referred to the sample mean. Okay, this one is a sample mean number 1. This one is sample mean number 2. This one is sample mean number 3. This one is sample mean number 4. Of course, we observe the sample mean, we can see that they are different in the sample mean. But we cannot just based on this descriptive statistic and then we make the conclusion. To make the conclusion, we need to carry out the hypothesis testing. So this one is why the ANOVA work for testing more than 2 levels of the RF power. So the H0 we're testing mean is equal. Okay. So I don't want to do it all together. I will do it separately. So it might seem that this problem could be solved by performing a t-test for all the 6 possible combination of mean. But it's not the best solution. Why they have a 6 here? We can be carrying out that is one. H0 mean 1 equal to mean 2. We are testing this pair. Or we can testing the H0 mean 1 equal to mean 3. We are testing all the 6. Okay, because we're testing the pairwise. So therefore, we can use a t-test. We're testing the first pair, you use a t-test. We're testing the second pair, the third pair, the fourth pair, and the fifth, and the number 6. So it's possible we carry out one by one. But why we don't want to do it one by one? Instead of we want to test all together. So this one will lead you to the following statement here. Performing all the pair and inflated the type 1 error. Okay, in the hypothesis testing, every time when we want to carry out one of the hypothesis testing, we need to set for the probability of type 1 error. Okay, means that we give the notation as a alpha. We always will set a type 1 error. Let's say you carry out this test, you allow for the 5% of the error. If you carry out the second test, you allow for the 2% error. Okay, because you need to allow for the certain percent error because your data is come from the sample. The sample definitely may not be perfectly represent the population. So means that when we carry out the hypothesis testing, we need to allow for some error. So the percentage of error cannot be very large. You will set the certain level of the error. Okay, so if you're performing 6 of the tests, let's say the first test you allow for 1 error, the second test you allow for the second error, and so on. All of them have a type 1 error with a certain value. So you can imagine that because all these tests you run it separately, the first test is run it separately. So all of them out, then they can have a error will be increased. Later on you can see that the overall error. Okay. So performing all the pairwise comparison in efficient and inflated the type 1 error. So let's say we want to see here. Now, if I carry out all the mean at the same time, I only do the one test. Suppose all the means are equal. If so, we select the alpha is 0.05. So the alpha 0.05 means that the 5% of the error, you allow for the 5% of error. So means that the probability of reaching the correct decision on any single comparison is 95%. Okay, because you allow for the 5% of error means that you have a 95% will confident that your test will be correct. Okay, so this one is say that if we carry out this thing, we can maintain at the 95%. If we set the 5% error, you can maintain at the 95 if you do it all together. So what happened with the following one? If you do it separately, one by one, so you can see that for each one of them, you will have a error is a 5%, and then the doing the correct decision is the 95%. Okay, so the second one also the same thing, and so on. So altogether, what is your total probability you have? So however, reaching the conclusion on all the 6 comparisons are considered less than 0.95, less than this number. Because this number you only carry out one test, you can maintain your decision, correct decision, the probability of reaching the correct decision at 95%. But if you're doing this way, you can see that for the you do it correctly is 0.95. But because you do it separately and then independently, therefore, if I want to calculate the second one, doing the correct one, is multiplied by 0.95 and so on. So you have a 0.95 power of 6 because you do it independently. So therefore, you have the probability 0.95 power of 6. So 0.95 power of 6, you will get your probability of the correct one is only 0.735. So the probability of reaching the correct decision on any of the comparison is only left until 0.73. So you cannot tell the people that you carry out this test, your accuracy is until 95%. You can see that if you do it separately, you only can achieve until 73.5% only. So this one is say that why we do not do it separately in the pairwise form, we will do it together. So this one is the reason why we need using the ANOVA to test all together. Okay. Okay. So can you follow until now? For those of them, for those students who don't have any background on this thing, can you follow? Okay. Okay. I don't hear from you all means that I think that you can follow. So let me continue for the one more slide before you take the rest. Okay. So I just show you the representation of the data, so that later on how we want to break it out to the different component, then you can be more familiar with. Okay. So the following one will be here. The analysis of variance for the single factor. So the arrangement of the data, when you key in your data in the software, also the same thing. Okay. So you have a treatment levels, we call as a level here, the first level until the A levels. For each level, you repeat for the N observation. So you have a Y11 until Y1N. Okay. So this one is a quite standard notation, as I mentioned to you, is using the Y for the response variable. And then for the each row, because you have a treatment 1 or the level 1 until the level A, so for each row of them, you can get the total. And then you also can get the average value. Okay, so the notation we use it for the total along the each of the row. It depends on your diagram. You can be rotate the diagram, become the column wise. Now I write in the row wise. So the total, we will always use a Y1 dot. 1 is referred to the first level. Dot means that you total out for all of them, for all the observation. So it's the first one. And then you get the average value, you use a Y bar 1 dot. Okay, to represent the average for the first level. Similarly, for the average for the second level from Y21 until 2N were given by the Y bar 2 dot, and so on until you get the last levels A. You have YA1 until the YAN will be Y bar A dot. Okay, so this one is referred to the average value for each of the. Okay, and then you get the overall total. The overall total, basically, they will use the notation as a Y bar double dot. Okay, or the total is a Y double dot. Okay, so this one is a Y double dot. It means that the total out all the observation, you will get the Y double dot. Y bar double dot, it means that the total out all the observation divided by total observation, you get the average value. Okay, so these are the notation here, so that later on I show you the formula, you don't be confused. Okay, so in this diagram again, we will say that the A levels consists of the A levels of here of the single factor, or we call as a A treatments. Okay, different book they use a different the terms. Okay, and each one they consist of N replicates. They repeat for the N times, and then they must be run in the random order. So how they run in the random order? Once you get your observation first, then you assign it randomly. you need to do the randomization and then you assign randomly. You cannot say the first person, the first person is come, they must be go to the first treatment. The second person come, must you go to the second treatment. Okay, so in that case, it's not the random anymore. Okay. So this test is called the completely randomized design because you completely randomize the observation. So the third one is there are totally A times N total runs or the total observation you have. Okay. And then this one is another key word is a fixed effect case. Okay, the fixed effect case is means that we only study from the level A until 1 until the level A. So this one is we fix the level here. So therefore this one is called the fixed effect case. Okay, there is another case is called the random effect case. So this one I will explain to you later. Okay, so the objective of this study is to test the hypothesis on the equality of the A treatment mean. So means that we are testing the H naught, the mean for the 1 equal to mean for the 2, or the mean for the A. You have an equality of the A treatment means. Okay. And then just now I refer to the fixed effect here. If I recall back to you here, let's say this example, I want to study for this 4 power level, means that my conclusion only can be made for these 4 levels only. So this one is called the fixed effect case. Means that you already fixed 160, 180, 200, and 220. You cannot say I later on after I get this thing, I found that the maximum will happen at the 210. So you cannot make the conclusion for that one anymore. Okay, so this one is called the fixed effect. Your conclusion only can be made on this fixed level you have considered. Okay, so we have another case is called the random effect, but the random effect I will show it to you. I will explain to you later. Okay, so I think this one is an introduction for the parts of here, the introduction here. Later on, we will continue for the following slide. Okay. So can we take the break? Okay. We can take the break for the half an hour. Okay. So we stop at the we start at the 8 o'clock. Is it fine?
Okay.
Huh? Yeah. You can. Yeah. If you have any question, you can ask me. Okay. I stop